Hey, what's up everybody, and welcome back to another video. So in this video, we're going to go over a bit of an advanced Go concept called composition. Now, understanding how to use composition in Go is going to substantially increase your ability to write more robust code. And if you've been following along with my videos, then we've been going over some more advanced concepts in the Go programming language following all of my videos on concurrency. And that's because I'm trying to cover pretty much everything that you need to know to go from being a beginner Go developer to a more advanced or senior level Go developer. So basically, I'm going to continue to go over all of the more advanced Go concepts, and you'll be able to essentially add those to your tool belt and continue to level up your skills from there. But with all of that being said, if you're a long time watcher or you're somebody that's been able to benefit from my style of teaching, I do have a full course on microservice architectures using the Go programming language, which will be linked in the description below. So feel free to go and check that out if you want to support me and what I do, or you just want to learn about microservice architectures in Go. But without further ado, let's go ahead and get into the explanation of composition. Okay, so let's imagine that we have two cars here. So one car is a convertible and one car is a truck. And the convertible, since it's a convertible, the top can be put up or down. And the truck, we'll say, has four-wheel drive. So the top being able to go up or down, we'll just call it convert top. And the truck having four-wheel drive, we'll just say four-wheel drive. So those are the unique characteristics or capabilities between the truck and the convertible, right? Like the truck can't convert top and the convertible doesn't have four-wheel drive. So those are the unique characteristics between the two cars. But both cars are also going to have like shared characteristics or shared capabilities. For example, both cars are going to have an engine, and I can't draw an engine, so I'm just going to put a square. Both cars will have a transmission and both cars will have a steering wheel. So that means both cars are going to have the shared ability to start the engine, and both are going to have the ability to shift gears, and both are going to have the ability to turn. So as you can see here, we have two cars or two vehicles here, and aside from these unique characteristics or the one individual characteristic, like the convertible can convert its top and the truck can use four-wheel drive, all of the other capabilities are the same. Like both of the cars can start the engine, both of the cars can turn, and both of the cars can shift gears. So if we were to take a naive approach when translating this to code and we were to just create types for both convertible and truck, it might look something like this. So both of them would have methods to start the engine, both of them would have methods to shift, and both of them would have methods to turn. And then the convertible would have the ability to convert top, and the truck will have the ability to toggle four-wheel drive. And of course, you need to imagine that we need to write the implementation for all of these methods for these types, right? So what does that mean? That means that we're going to need to duplicate this code for both the truck and the convertible. So we're going to have to implement start twice, shift twice, turn twice, and these are the only two that are different between the two. So this is the naive solution. This is the solution without making use of composition. And the negative implications of these naive solutions are pretty obvious, right? Like, so if the start functionality and shift and turn functionality is the same between the two and we're duplicating the code, what if one day we need to change, for example, the start functionality? That means we're going to have to go and change it twice. And God forbid we add another car with this same start, shift, and turn functionality, then we need to go and update start 3 times. We need to update it for in cars, right? So most of you have probably already realized we need to find some way to essentially share this functionality. So that way, if we need to update the start implementation, it would apply to any car that's using this shared functionality, right? For example. And we can do that by making use of composition. So now we're going to get into what composition is. And it's actually quite simple and it's intuitive as well, so it shouldn't be too difficult to understand. So what we're going to do is we're going to break apart the underlying components of the cars. So what are the components of the cars? Well, a car has an engine, a steering wheel, and a gear. So we're going to break apart those components. So let's go ahead and do that. So we'll have an engine component, a steering wheel, and a transmission. And then for our cars, we'll have convertible and truck. Now remember, the engine component is going to have the start functionality, the steering wheel component is going to have the turn functionality, and the transmission component is going to have the shift functionality. And then remember, the individual car types had their own specific functionality that wasn't shared, right? So the convertible had convert top, and the truck had toggle four-wheel drive. So what is composition? Composition is just us composing all of these individual components together to create some specific thing. So for example, if we want to create the convertible like with this functionality here, we're going to compose these individual components together with the convertible. So let's take the engine component, the steering wheel component, and the transmission component and compose it together to create the convertible here. And let's do the same thing for the truck. So now the truck that we composed has the functionality to start, turn, and shift, as well as its own specific functionality for four-wheel drive. And the convertible has the functionality to start, turn, and shift, as well as its own individual functionality to convert top. So we've composed individual components together to create some specific thing, right? The convertible and the truck. And that is composition. Now, the benefits here should be pretty obvious. So now, if we make any changes to transmission, like say we want to change the way shift is implemented, like the behavior of the shift functionality, that's going to propagate down to any component that embeds that particular transmission component. And the same thing for steering wheel. If we want to alter the way turn functionality works, it's going to propagate down to whatever component embeds the steering wheel component. So it's a composition of individual components to create something in particular. And that's what composition is. And this is very powerful because as you can see, we were able to reduce code duplication while at the same time completely decoupling our components, right? So the transition functionality is encapsulated within its component, the steering wheel functionality is encapsulated within its component, and the engine functionality is encapsulated within its component. So from the perspective of truck or convertible, we don't necessarily need to focus on the functionality of these individual components. We just need to focus on our individual or specific functionality. For example, for truck, it's four-wheel drive. And that's because we can take this a step further and we can actually create interfaces for each component. Now, this is where it's going to start to get a little bit tricky, so try to pay attention here. So what if we wanted to truly decouple the components? Well, in that case, we could define an interface or multiple interfaces. So let's use truck for example. Let's say that we defined the interface for an engine, an interface for a steering wheel, and an interface for a transmission. And if you don't have a strong understanding of interfaces, I suggest you watch my video on interfaces and then come back to this video and continue. And I'll link that video in the description. But what this is essentially going to look like is this. So the engine interface, in order for a component to be able to plug into this interface, it's going to have to implement the start method. So we'll say engine interface requires start, steering wheel interface requires turn, and transmission interface requires shift. And really quick, we're going to go over code examples of this as well. So if you're not completely understanding it, bear with me and just continue to try and understand it as best you can. So we've now defined these three interfaces, right? And in order for components to be composed into truck, they need to implement these interfaces. And this is going to end up completely decoupling the truck component from the engine, steering wheel, and transmission components. And it's also going to make which components we use in truck more flexible. So for example, what if we have a different type of transmission? So let's say we have enhanced transmission. As long as this new enhanced transmission implements the shift method, then that means it conforms to this interface, which means that it can also plug into this interface. So we're then provided with the flexibility of being able to plug multiple different types of transmission into our truck or compose multiple different types of transmissions with our truck. So as long as they implement these shift methods, the truck doesn't care about the underlying implementation details as long as the implementation conforms to the interface. So then from the perspective of the truck, since the interface defines the contract contract between the truck component and the transmission component. The truck knows that the transmission component is going to have this shift method. So within truck, we can call the shift method and we don't need to care about the underlying implementation. So just for the sake of example, let's say we have some truck code here. So this is the code for truck. And in truck, we're calling shift. We know that we have this shift method available from the transmission because the transmission conforms to the contract, which says that we need to provide shift from transmission's implementation. So if transmission changes its implementation of shift, as long as it provides the shift functionality as per this contract, we don't care from the code perspective of the truck what happens within the encapsulated functionality in transmission. It's completely abstracted away from the truck's perspective. Now, it might seem like it's getting a bit confusing, but that's just the interface stuff. So we'll go into a code example and I'll explain the interface stuff a bit further. But for the most part, what you need to understand is what composition is, which is what I told you before. It's when we compose together individual components to create something in particular. So let's get into a code example. All right, so let's start by building out the individual components themselves. So we'll do each component in its own file just to kind of separate things and make it less confusing. So we'll start by doing the engine component. So we'll create a file called engine.go, and all of these are going to be package main. And from here, we're going to create the struct for engine. And we also need to go ahead and create the start functionality. And the start functionality is just going to print engine started. And we'll go ahead and do the same thing for the other components. So we'll do transmission, which is still package main. And again, we'll create the struct for transmission. And transmission is going to have the ability to shift up and shift down. And same thing for steering wheel. It's going to be package main, and we're going to create type steering wheel, which is a struct. And for steering wheel, we're going to do turn right and turn left. And we can just copy this one over and just change it to left. And you'll notice I use this syntax here, which is just associating these functions here with this particular struct here. So in simple terms, this just means that these functions belong to this struct essentially. So now let's go ahead and create our components for the convertible and the truck. So we'll start with the convertible. So we'll do convertible.go. And again, it's going to be package main. And this is going to be slightly different, but pretty much the same. We're going to need to create the struct for truck, but within this struct, we're going to embed the other components. So we're going to do engine, transmission, and steering wheel. So at this point, we're embedding these types into the truck type. So the syntax for embedding in Go looks like a field without a name. So for example, if we were to say we have another field here called model, and we say it's type string, this is the field name and this is the field type, right? But for embedding, we're just putting the type. We're not putting a name for the field. And that's the syntax for embedding in Go. And I'll show you how that works a little bit more in a second. But just know that we're embedding these other components, the engine component, the transmission component, and steering wheel component into our truck component. We're composing these different things together to create the truck. So we're making use of composition here. And then we're going to have our truck specific functionality. So we'll say func t truck to associate this function with the truck struct. And we're going to say 4-wheel drive, just like in the example. And again, we're just going to print toggling 4-wheel drive. And I made a mistake here. This is convertible, but I did truck, but it's fine. We're just going to go ahead and change the name of this file to truck.go. And then we'll go ahead and create the one for convertible as well. And it's going to be pretty much the same thing. We're going to do type convertible struct, and it's going to embed the engine, the transmission, and the steering wheel. And then it's going to have its own specific functionality for convertible, which we're going to associate with convertible by using the syntax here. And we're going to just say convert top. And again, we're just going to print. So now we have all of our components here, and to create the truck component, we're composing the individual engine and transmission and steering wheel components, and the same thing for the convertible. We're composing the engine, transmission, steering wheel components to create the convertible, and that is composition. So now let's go ahead and create our main function. So package main, and then we'll just create the main function. Now within main, we're going to go ahead and create a convertible and a truck. So we'll do my convertible equals, and we're going to build a convertible. And in order to build it, we're going to need to pass in the engine, the transmission, and the steering wheel. And as you can see, if we go to definition for these, it's the transmission, steering wheel, and engine that we just created. So we're creating a convertible here, and we're creating an engine here, and a transmission here, and a steering wheel here. And all those things are being composed together to create the convertible. And we'll do the same thing with my truck, but we'll change this to truck. So now you'll see that if we do my convertible dot, you see that it has the functionality for the engine, the transmission, and for the steering wheel. So all we have to do is we can just select my convertible dot start, and we can do the same thing with my truck. We can do my truck dot start. But what we can't do is we can't do my convertible dot four-wheel drive, because this doesn't exist for the convertible, right? So let's go back to truck again, and I accidentally named this four-wheel driver, but let's make that four-wheel drive. Now for my convertible, as you can see, we can't do four-wheel drive, but what we can do is we can do convert top. Because remember, convert top is specific to the convertible, and four-wheel drive is specific to the truck. So for the truck, if we do my truck dot convert top, you see that it doesn't work. We're getting an error here, but we can do four-wheel drive because it's a truck. But then as you can see here, they can both do start, they can both do shift down, they can both do turn left. And that's because both of them share the behavior from the shared components, which are the engine, transmission, and steering wheel, but they have their own individual behavior as well. So this makes things a bit more flexible for us. Like for example, say if we wanted to create some function up here, and we wanted to create a function that starts all the car's engines that are passed into this function. So we'll do start engines, and it's going to take in cars, and we'll make it a variadic function, and we're going to say that it takes in cars that are startable. Now as you can see here, startable doesn't exist at this point, so we're going to go ahead and create an interface. We're going to do type startable interface, and we're going to say that any type that implements the start functionality is going to conform to the startable interface. So that means that if we pass in a car here, if it implements start, it can be considered startable, so it can be passed into this function. And then we can go ahead and do for car and range the cars. We're going to do car.start. So now if we go down to our code here, let's go ahead and remove all of this to make some room here. We can just do start engines, and we can pass in my convertible, and we can pass in my truck. And since both the convertible and the truck embed the engine, which has the start functionality here, then that means that both the truck and the convertible implement this startable interface here that says that in order to conform to this interface, you need to implement start. So therefore, we can pass both of them into this start engines function. So what you're seeing here is a combination of both composition. So we're using composition when we're creating the convertible and the truck, and polymorphism. So we're using an interface here to define the contract for the cars that get passed into start engines. And regardless of the underlying implementation of start for each individual car, we're still able to use this same code block on any car that's passed into this function here. And that is polymorphism. But don't worry, polymorphism is something I'll cover in a different video altogether. But as you can see here, this is how composition can come together to help you to create more robust code. Now, what if we wanted to take this a step further? What if we wanted to go here and create another transmission? So we'll say enhanced transmission.go, and it would still be package main, and we'll do type enhanced transmission struct, and we'll create the functions for shifting up and down, but this time shifting up and shifting down is going to be some enhanced variation of shift up and shift down. So we'll just do format.println quick shifting up, and just use your imagination for this part. This is an enhanced transmission, so maybe it has a quicker shifting capability or something. And we'll do the same thing for shift down and quick shifting down. Now, if we were to go to, let's say, the convertible, for example, so right now we wouldn't be able to use this enhanced transmission for transmission. For example, if we go to main here, if we try to replace transmission with enhanced transmission, you can see that we're getting an error here. And that's because the convertible specifically accepts transmission, which is the regular transmission here, not enhanced transmission. But what we can do is we can use an interface. So let me show you what I mean by that. So we'll do type and we'll just say transmission interface. And we're going to say you just need to implement shift up and shift down. The underlying implementation doesn't matter. Just implement those and then you satisfy the contract. And here we're just going to replace this with transmission. So what is that going to do? So now if we go back to main here, you'll notice that the error is gone. We're using enhanced transmission, which is not this transmission, but since the convertible, we changed the requirement here, we're now allowing any transmission that implements these two methods to be passed in here via this interface. So if the transmission conforms to this interface, it can plug into our convertible. And enhanced transmission just so happens to conform to the interface because it implements shift up and shift down. So now if we go back to main here, it's still the same situation. We can do my convertible dot shift up, or shift down rather, and shift up. And now it's going to be using the enhanced transmission. So let's go ahead and run this code really quick. So if we ls here, you see we have all of our components and we can do go run. And I forgot to create a module. So we'll do go mod init, go mod tidy. And then let's clear and let's ls here. So we have our go mod files. So now we can do go run and then just the directory. And as you can see here, we get engine started twice because we're starting all engines of both of the cars when we pass it into this function here. And then as you can see, since we're using the convertible shift method and since we've plugged in the enhanced transmission into the convertible up here, as you can see, then we're getting the quick shifting functionality. But if we change this here, let's change this to use the regular transmission. And remember, the regular transmission still implements the shift up and shift down, so it can be plugged into the convertible. So if we change that to the regular transmission and we run this code again, you see that now we're just getting a normal shift up and shift down. Now, the last thing I want to show you is how this in fact is completely decoupling the components, the use of the interface, for example. So if we go into the truck here, you see that the truck requires these specific types, right? So what if we were to go into engine here and change the name of this start here? What if we were to change it to stall or something? If we go back to main here, you see that there's still no issue with using this engine in this truck. That's going to actually cause some other issues down the line, right? Because remember, start engines requires the start functionality to be implemented, which was the original functionality of engine. But now that we've changed the name of the start function to stall, it actually breaks this code here. And even down the line here, if we were to do my truck dot start, it would have also broken that code as well. But this could cause confusion, right? Because we're still able to compose the truck with this engine, even though this component doesn't have what we expect it to have down the line here. So the thing about using interfaces is with interfaces, we're defining a contract. So it means that both sides need to conform to the contract. So this engine would need to conform to the contract that we define in truck or convertible. But here we're not having a contract. We're just saying we take in a specific type. But again, we're tightly coupled with this specific engine type. Like, for example, if we go to engine here, what if they just change this to E for engine? Again, if we go to the code here, this is broken now because if you go to truck or convertible, you see that it expects that specific type engine. So we're tightly coupled with that original engine. But if we use an interface, we don't care about the type as long as it implements the interface, right? So if we were to just do type engine interface, and we're defining the contract for the interface as needing the start functionality. And if we were to change this here to just engine, now if we go back to this engine type, it doesn't matter if we change the name here to E And if we have this stall here, that's fine as well, as long as we conform to the contract of the interface, which says that we need to have start as well. So then when you go back to convertible in this case, or sorry, not convertible, truck in this case, since what we require now is that whatever we pass in for engine implements the interface, which means it implements start, we're not tightly coupled to the type of struct that gets created to be passed in as engine. Like, we don't care what the name or the type is here. We just care that it has this start functionality, right? And the same thing for convertible. We could change this to engine, and it might be a bit confusing that that worked, but it's because we're still in package main. So of course, engine is part of package main, so we can still use this interface even though it's in a different file. But as you can see here, regardless of what changes we make to engine, like if we change this to some dumb name, and we make the implementation print engine started multiple times, if we go back to main here, we can still pass in some dumb name as the engine type for both convertible and truck, and we could even just do nothing. So we could just completely erase that. So in main, we can still pass in some dumb name where the implementation for start essentially does nothing. It's still able to be passed into here because some dumb name, the type some dumb name, still conforms to the engine interface. So that's why they're completely decoupled. And whenever you're confused about whether or not something is completely decoupled, you can just imagine it as being from the perspective of two teams. So imagine that you're a member of the team that's working on convertible code, and there's an entirely different team that's responsible for the engine code. This team can work on the engine code in complete isolation from the convertible code, and the convertible code can work in complete isolation from the engine code, and that's because of this. So let's imagine this convertible code and the main code. It's the same team working on both convertible code and main code. So if we have the main code here and we do my convertible.start, and we just have a bunch of starts here, right? And that's our code. So then let's switch perspective. Let's imagine we're the team working on the engine code. And what if we say, oh, this start functionality, it's not performant. Let's improve the performance. So let's just say we had some code here to improve performance. And I don't know, let's just say print line performance is good. From the perspective of the other team that's working on this code, we don't need to change anything, right? We can just leave it the same because we're just using the start functionality that's provided to us by them. But the implementation that they provide for start is a black box from us. We only see the interface. So we just know that they're going to provide that functionality. We don't necessarily care about how they're going to provide it. And that's how you know they're completely decoupled, because two separate teams can work on these components in isolation without needing to know what's happening on either end of the interface. Now, I know it got a little bit convoluted. I just wanted to kind of give you the explanation of composition in the context of a way that it might be used. But anyways, that is composition in the Go programming language. Understanding this is going to significantly improve your ability to write efficient and performant Go code. But yeah, if you made it this far in the video, don't forget to leave a like. And if you want to see more videos like these, go ahead and subscribe if you haven't already, and I'll see you in the next one.